So we'll continue with the second class, that is based on again basics. We'll see some of the problems now. A 10 liter of a liquid weighs 350 Newton. Find specific gravity and density volume of a liquid. So here what is given, you please understand. So 10 liter it is given means you need to convert into meter cube. So it means if it is a meter cube, it is a unit of what? It is a unit of volume. So 1 liter is equal to 10 raised to minus 3 meter cube. So 10 liters is equal to 10 into 10 raised to minus 3 meter cube. And weight is given, not mass. So what all you have to find out? Specific gravity. What is formula of specific gravity? Density of any liquid to the density of water. But density you don't know. So if you want to calculate the density, mass by volume, you can do it. So mass by volume is what? Mass is not given, so weight is given. Weight is equal to 350 Newton. So if you want to convert to mass, so you need to divide by acceleration due to gravity, that is 9.81. So it comes around 35.67 kg. So here mass by volume is given 10 into 10 raised to minus 3 and mass is 35.67. So answer comes around 3567.78 kg per meter cube. So weight density he has asked, means weight per unit volume. So weight is 350 Newton, volume is 10 into 10 raised to minus 3, 35,000 Newton per meter cube. Density, difference between mass density and weight density is, it is Newton per meter cube, that is kg per meter cube. If you just divide by 9.81, it becomes mass density. If you just multiply by 9.81, it becomes weight density. So similar problem we are going to solve here. If 10 meter cube of mercury, so 10 meter cube means what? Volume is given, weight is given 1329 kilonewton. Calculate specific weight, mass density, specific volume and specific gravity. Specific weight is what? Weight by volume. Weight is given 1329, volume is 10, so 132.9 kilonewton per meter cube, because weight is given in kilonewton. So if you want to convert, you can convert into Newton per meter cube. Mass density. Mass density is what? We know that or density you can calculate. There are two methods. One is weight density is equal to density into gravity, or else you can calculate density is equal to mass by volume. So mass, how you have to calculate? 1329 divided by 9.81, you will get mass. Gravity is and the volume is 10, or else you can directly, one more formula is weight density divided by gravity, will get a mass density. Specific volume is 1 by density, that is reciprocal of a density is specific volume, and specific gravity is mass density divided by density of water. So mass density is 13547 and density is 1000, so 13.56547 is the specific gravity of mercury. So one more problem we are going to solve here. Calculate the specific weight, mass density, specific volume, specific gravity. All the four we have to calculate. Volume is given as 4 meter cube and weight is given. Same problem you need to solve again here. Please solve and check your answer. So specific gravity comes around 0.75. Next, calculate the specific weight, density, specific volume. 1 liter of petrol weighs 6.867 Newton. So what is given? Weight is given, volume is 1 liter. 1 liter means what? 10 raised to minus 3 meter cube. Weight is given. So density how you have to calculate? S into that is rho into G. Here density is given. So density you have to calculate. How to calculate this one? Density mass. This is whatever this gamma signal is. This Y type signal is there, no, that is weight by volume, that is specific weight. So specific weight already you know that 6.6867 Newton per meter cube, and weight is also known. So you please take down the basic formulas and calculate the things. Just check your answers. Specific gravity is given directly here. So if you get a specific gravity, you can get the density, because specific gravity is equal to density divided by density of standard fluid. Standard fluid is uh, water. So water standard, what is the density? Density is, and 10 liters of liquidities. So you can calculate the density is 700 kg per meter cube, and other things you can calculate very easily. Next one, we will go for surface tension. Surface tension, it is a interface is the boundary between two or more phases exist together. The property of the molecules forming the interface are different from those in the bulk that the molecules are forming the interfacial phase. We'll explain. So water has a special property, it is called surface tension. What is surface tension? Surface tension is the ability of water molecules to let the things with a very low mass float on top of water. That what is that? Surface tension is the ability of water molecules to let the things with a very low mass float on a top of water. Suppose here insect is floating on water. How it can float? Because it has some tension over the surface of the water. So things like paper clip or water strider are able to float on top of the water because of their small masses. Surface and interfacial tensions. There are two tensions. One is surface and interfacial. In the liquid state, the cohesive forces between the adjacent molecules are well developed. For the molecules in the bulk of the liquid, they are surrounded in all directions by other molecules for which they have an equal attraction. So what is cohesive force? Attraction, the force of attraction between the like molecules. Only attractive cohesive forces which with the other liquid molecules, they can develop adhesive forces of attraction with the molecules of the other phase of interface. So surface tension is a phenomena in which the surface of a liquid, where the liquid is in contact with gas or immiscible liquid, acts like a thin elastic sheet. See here, what is that? If it is between liquid and gas, then only it is called as surface tension. If it is with the liquid and liquid, it is called as interface tension. This explains the characteristics rounded shape that liquids form when dropping through the air. See here, you can see the tension. So only there is a connection between the tap and water droplet. So we'll see the expression now. So let sigma be the surface tension uh, of a tensile force. So one more important unit is unit of surface tension. You will be asked in all exams, that is Newton per meter. Surface tension is Newton per meter. So P is the pressure intensity inside the droplet. We will see for the liquid droplet. D is diameter of droplet. So circumferential, the tensile force due to surface tension acting around the circumference of the cut portion and is equal to sigma into circumference. Circumference is pi into d. Second one is pressure force. On the figure shown below is, see here, surface liquid droplet, surface tension and pressure forces. Surface tension act outside, pressure force act inside, so we'll make it equal. Will be equal to the under the equilibrium conditions, P into pi by 4 d square, that is pressure into area, is equal to stress into, that is surface tension into pi d. So if you just modify it, you will get P is equal to 4 sigma by D. 4 sigma by D, 8 sigma by D, and 2 sigma by D. So these are the three surface tensions for bubble, liquid jet, and for hollow.